This is Dr. Mohaga, and today we'll be talking about energy resources. In this lesson, we're going to talk about how useful energy is obtained from different sources, and we're going to talk about the advantages, disadvantages of each and every one, and understand qualitatively the concept of efficiency of energy transfer. Let's start with fossil fuels. How do fossil fuels work? Coal, or any fossil fuel, is supplied to a boiler where it's heated up. Now, there's a tube of water that is passed on from my water supply. So the water supply is over here. It supplies the water. The water moves on to the boiler, heats up, so the steam coming out from the heated water goes through the steam line, moves on to the turbine. The steam makes the turbine rotate or move, which results in the kinetic energy of the turbine being transferred to electricity through the generator. Whatever is left from the water goes down again to the condenser to be cooled and moved again to the boiler, and the cycle continues. So fossil fuels such as coal, oil, and natural gas contain chemical energy stored over millions of years from dead plants and animals. Fossil fuels are burned in a boiler to heat water and produce steam. The high-pressure steam spins a turbine, which is connected to a generator, converting the rotational kinetic energy to electrical energy using electromagnetic induction. This is the most common method used in thermal power stations and the most common method which we are currently using nowadays. Next, we have biofuels. This is a bit different than fossil fuels. Biofuels are made from recently living biological materials like crops, animal waste, or algae. They are renewable and they can be replenished over short timescales. This means that if I use plants or crops to make my biofuels, the seeds from the plants and crops can be replanted to make more plants and more crops within a short period of time. Biofuels like biogas or ethanol are combusted or burned in a boiler to produce steam, just like the fossil fuels. The steam drives a turbine which turns a generator to produce electricity. Biofuels can also be used directly in internal combustion engines for transport and backup power generators. Water. We have three kinds of water sources that we use for energy: waves, tides, and hydroelectric dams. Water is a powerful source of renewable energy, such that waves, where the motion of sea waves drives pistons or floating devices that move magnets through coils, generating electricity directly. Tides. As tides rise and fall, water flows through sluice gates and spins underwater turbines connected to generators. So for tides, we need the turbines and generators. Hydroelectric dams. Water is stored at a height in a reservoir. So here we're talking about gravitational potential energy. And then it's released to flow down through large turbines. So hydroelectric dams also needs a turbine and a generator. So waves do not need turbines, generators. Tides and hydroelectric dams do. In hydroelectric plants, water does not need to be boiled. It already has kinetic energy due to gravity. So the falling water spins a turbine, which turns a generator. Next example is geothermal resources. Geothermal resources is very, very easy. They use heat from the Earth's interior to generate electricity or directly heat buildings. First, the cold water is pumped deep into Earth, where it's heated by hot rocks. So the water goes through the injection well, gets heated with the geothermal zone, so underground heat, to be released as steam through the production well. The hot water or steam returns to the surface. The steam then goes to the turbine, makes it turn, which turns on a generator to be transferred to electricity. No boiler is needed because the Earth's heat is the natural boiler. Geothermal plants are most effective in places that have volcanoes or the tectonically active areas. Next, we have nuclear fuel. Nuclear power stations use the energy released from a nuclear fission reaction in radioactive fuels. Like uranium 235 or plutonium 239. Do we need to know those names? No, but it's good to know what they are. The nuclear fuel undergoes fission, releasing large amounts of thermal energy, which is used to heat water in boiler to produce steam, which drives a turbine connected to a generator to give me electricity. Nuclear fuels provide high energy output, and they have no carbon emission during operation, but produces radioactive waste that must be safely stored. Light from the sun to generate electricity, solar cells. Solar cells, also known as photovoltaic cells, convert light energy directly from the sun into electrical energy using semiconductors such as silicon. When sunlight hits the solar cell, the electrons in it are excited, causing current to flow. We do not need a boiler or a turbine or a generator in solar cells. Solar cells are used in calculators, rooftops, solar farms, and satellites. They work best in direct sunlight and are silent, non-polluting during operation. Next, we have infrared and other electromagnetic waves from the sun used for solar panels and wind. Infrared and visible light from the sun heats surfaces like water or land, where energy is captured or transformed into other useful forms. Solar panels, they use the heat. Solar panels heat the water using sunlight. The hot water is stored or circulated through buildings for domestic use. Wind energy, the sun heats the Earth's surface unevenly, causing air to move, which is known as wind. Then we use that wind with the help of wind turbines to generate electricity. So the moving air turns the blades of the turbine and then it's connected to a generator to produce electricity. Neither wind nor solar thermal systems require traditional boilers. Here's an example. Pause the video, try it on your own, and then unpause to check your answer. A small island community wants to switch from diesel generators, which are fossil fuels, to renewable sources of electricity. The island has strong sunlight, reliable wind patterns, and a nearby mountain stream. Residents are considering those options. Which option would provide the most consistent electricity supply and why? The correct answer is to use all three. You can pause the video to read it slowly, but the most stable and consistent of the three options is the micro hydroelectric system, because for solar panels at night time or if the weather is cloudy, you're not going to get direct sunlight. For the wind turbines, if there's fluctuation in the wind speed, then the turbine will not generate that much electricity with the generator. So ideally, the three of them should work, but micro hydroelectric system will be the most stable and consistent of the three options. Comparing methods of electrical power generation. Here I've added a small table that has the comparison in terms of if they're renewable or non-renewable, their availability, reliability. If they're reliable, that means whenever you want them, you can use them, regardless of day or night, windy or not windy. So here we're talking about energy resources that are always available. Scale. To what scale do we have this kind of energy source? and if they have an environmental impact such as pollution or emissions that are being released to the environment. Here's another example. You can try it on your own and then unpause the video when you're done. A developing country plans to build a new power station to provide electricity to a large rural area. The government is considering the following options: coal-fired power station, solar power farm, and hydroelectric dam. We need to talk about the advantages and disadvantages of each in terms of availability, reliability, environmental impact, and its cost and scale of generation. Then I'd recommend which option would be the most suitable. Here is the answer, looking at the three options in terms of the four requirements they asked for. From all three options, if the geography permits, the hydroelectric option is the most suitable due to its renewability and reliability. If not feasible, a solar farm supported with battery storage is a clean and sustainable alternative. Coal should be the last resort because it has environmental drawbacks despite being reliable and cost-effective in short term. That's all for today. I'll see you in the next lesson. Have a good day.